welcome. In this podcast, we're going to be finding y-intercepts. So I decided we'd go back to functions we've already graphed and just find their y-intercepts. Sometimes you can find it from a graph. Sometimes it's not so easy to find from the graph. Right, so if you notice f of x equals 2 times the cube root of x minus 2, that's the red graph. Right? And I don't know what that point is. Right? But we can find the y-intercept pretty easily. Right? So remember, to find the y-intercept, you just set x equal to 0. And if we can simplify, we will. If we can't, we'll just leave it as a radical. Right? Your other alternative is to approximate with a decimal. We'll just leave it as a radical. Right? So here we have f of x equals 2 times the cube root of 0 minus 2. Right? Well, we can simplify that a little bit. F of x equals, and then we'd have 2 times the cube root of negative 2. All right, so technically, your y-intercept here, we plugged in 0 for x. We got 0. Actually, I didn't put f of x. I should put f of 0. Because we plugged in 0 for x. It's not any x. It's a particular x, f of 0. All right, so our y-intercept is 0, 2 times the cube root of negative 2. Can't really simplify that. Right? If you want, you could take the cube root of negative 1. Interestingly, that will come out. So by the way, this and this are the exact same thing. They're the same thing, right? Because the cube root of negative 1 is just negative 1. Right? And so interesting thing about the cube root graph, whether you reflect over the x or whether you reflect over the y, you get the exact same graph. Okay? So we'll pull out that negative because usually we change a rather than y if we have the choice. And sometimes with the cube root you have a choice. Well, at least on reflections you have a choice because it's the exact same thing. All right, so how about this one? Oh, on some of the graphs we'll also find the x-intercept. All right, we'll find the x-intercept from the graph. Right? So how about this one? Right? Could we find the x-intercept? Well, I think we can find it pretty easy from our graph here. So this one was our y-intercept here in red. Right? In case you're asked to find the x or y-intercept on a benchmark or formative, that was the y-intercept. From the graph, the x-intercept is easy to identify. So your x-intercept is the point 2, 0. So the y-intercept was funky, but your x-intercept was nice and easy. Right? And if you look at the red graph, you can just follow along. You can see 2, 0. Our graph definitely crosses at 2, 0. And that makes pretty much sense because x is going to have to be 2 for y to be 0, because I'm going to need this under the radical to equal 0. That's the only way I'm going to have y equal 0. And of course that means x is 2. Right, so we'll only find the x-intercept if it wouldn't be too difficult to find. All right, so here our y-intercept. Right, so g of 0 would be negative square root of 0 minus 4. Well, that is a complex number. Right? So negative square root of negative 4, that's a complex number. That's not a real number. All right? I mean, it's one of our imaginary numbers. It's an important number, but it's not one of our real numbers. Right? It's not part of the real number system. So there is no y-intercept. So you should be able to figure out if there's no y-intercept. And hey, look at the graph. The blue graph is g of x equals negative square root of x minus 4. Do you see it crossing the y-axis? No, right? It stops. Stops four spaces before the y-axis. The x-intercept's nice and easy to find. Of course, what would x have to be for the whole thing to be equal to 0? Of course, x would have to be 4, right? 4 minus 4 would give you a square root of 0, and you can see it right from the graph. Right? So no y-intercept, but the x-intercept is 4, 0. So does it have an x-intercept? They all won't have x-intercepts. That one did. All right, so let's look at another one. We'll find y and x-intercepts. All right, so here we got a square root again. All right, so y-intercept. This one I think is pretty easy. Our y-intercept, g of 0, that would be the square root of negative 0. So that's just 0 plus 3. That's just going to be 3. All right, so we got a y-intercept at 0, 3. Right, and we can see that from our graph. Right, but how about an x-intercept? Oops. Trying to move it down a little bit. I moved everybody. How about an x-intercept? Well, you can see that red graph does not cross the x-axis, and there's no number I could plug in for x where I'm going to get a negative 3, and that's the only way. So if this can't be negative 3, that whole thing can't be 0, right? And so there's no x-intercept, and you can see that from the graph. No x-intercept. Just a y-intercept this time. All right, so let's find another x and y-intercept. All right, so we'll find the x and y-intercepts here. All right, well, we can't find the x-intercept from the graph. There is an x and y-intercept. This one's just not so easy to find. Y-intercept or x-intercept. Right? We're going to get a pretty yucky number for both a y or an x-intercept. Right? So if I plug in 0 here, I'm going to have the cube root of 2 plus 3. So that's actually our y-intercept. I'll write it in. You're not going to be asked to find this kind of y-intercept on the formative. So our y-intercept, g of 0, would be the cube root of 0 plus 2 plus 3. That would be the cube root of 2 plus 3. Or 3 plus the cube root of 2. That's our y-intercept. Isn't that lovely? All right, I'll write it as a point. All right, so 0, I'll write the 3 first. And then 3 plus the cube root of 2 is the y-intercept. There's an x-intercept, but I don't know what it is. And it's not going to be pretty, because I'd have to have x plus the cube root of x plus 2 is going to have to equal negative 3. There's some number, okay, because our domain and range are all real numbers. There's some number that will equal negative 3, but for the cube root of x plus 2, but it's not pretty, and so we won't find it on this one. If it's not pretty, we're not going to find them. All right, so here, x and y intercepts. Right, probably help to move that little thing away. Right, so this one's really easy. Right, we can actually look right at the graph. Why don't we on this one? So our x-intercept, there is none. Right, that blue graph, that does not cross the x-axis. That's it. Its last point is right there. Does cross the y-axis, however. We have a y-intercept at 0, negative 1. So we can see that right from the graph. Right, if you plug in 0, right, to your equation there, you're going to have negative 1. Right, so that one was an easy one. Let's see if we have a few more before we stop. None of our y-intercepts have been very pretty at all, man. Let's skip this one. It's just getting worse and worse on the y-intercepts. Well, I didn't write these to be nice for the y-intercept. Here we go. Let's find the y-intercept here. This one would be pretty. All right, and this will be our last one. So y-intercept, right, would just be, we'll plug in 0. G of 0 would be negative 1/2 times the cube root of 0 plus 5. 0 is 0. Anything times 0 is 0. So g of 0 is 5, which means our y-intercept is 0, 5. Well, that was easy. And you can see that from the graph, right? There's the point. There's our y-intercept. How about the x-intercept? That one's not so pretty. Not so pretty at all. Has an x-intercept because it never domain, so there is an x-intercept somewhere. We're going to have it, there's an x value where y is 0. This part here would have to equal -5. So some number will do it, but it's not going to be pretty. And so maybe we'll just find the y-intercept on this one. Let's see if we got any other graphs that would be pretty. Define x and y. Let's see if we can find one x and y from our lessons. Not that one. Well, this one's an easy x and y. Well, it's an easy y. And there is no x, right? We have a y-intercept on this one. Is 0, 5. And if we plugged in 0, right, we'd have negative, well, plug it in. Yeah, so we have g of 0. That would be the square root of -1/2 times 0 minus 2 plus 4. Right, so that's going to be -1/2 times -2. Well, that's just going to be 1, right? So this would just be equal to the square root of 1 plus 4, and the square root of 1 is 1. So it would be 1 plus 4 or 5, right? So that's how you'd find it by plugging in, and then by looking at the graph, you can see it's 0, 5. Right? Because maybe they don't give you an equation on a formula, right? So then you would just plug in, right? And that's how you find your y-intercept. I don't know if I want to find any more x and y-intercepts. Let's see if we got anything from the ones we did. Well, we have no graphs there. And so we'll skip past this one. All the things that we've done. I just thought I'd end this with being able to find x and y intercepts. Oh, that one would be a good choice. Whoops. And, well, this one, of course, has a y-intercept, right? So our y-intercept is 0, 2. Right, if you plug in 0 for x, you get the square root of 1. Square root of 1 is 1, and 1 plus 1 is 2. Right, so we do have a y-intercept here at 0, 2. Could have used that point, by the way. One of these has an x-intercept because we used the x-intercept, and that was for the black graph here. Right, so this one has an x-intercept, but it has no y-intercept. Right. There's nothing that I could plug in that would make that y equal 0, right? Because I'd have to have something on, so we have the square root of x minus 1 minus 2. You can see it starts at 1, right? There's nothing, because I can't have, there's nothing I can plug in for so, yeah, nothing makes that equal to 0, right? Excuse me, nothing makes x equal to 0, right? So, right, because I have y equals, but that was really awkward to me. Why don't I just plug it in and show you, right? That's what I'm trying to say. I think for a moment, right? So if I plug in 0 for x, you can see that's imaginary, right? So there's just no way I can plug in 0 for x. That's what I meant to say. Kept thinking in my head of y-intercept when I really meant to say x-intercept. Right, so for y-intercept, you plug in 0 for x. X-intercept, you plug in 0 for y. Of course, this one has an x and a y-intercept. It's at 0, 0. And then our last graph had a nice x-intercept. How about the y-intercept? We'll find the y-intercept for this one. It does cross the y-axis, so there's our equation. So we have y equals the square root of negative 0 minus 3, and that's all. Right, and so that would be y equals, right, so it'd be negative 3, so y equals the square root of 3. So this is our y-intercept. Our y-intercept is the point 0 square root of 3. And that's the best of our irrationals that we had. At least that's a little bit simpler. All right, so just wanted to go over how to find x and y intercepts. Not every one of these graphs is going to have an x and y intercept. Your cube root will, but maybe it's a pretty value, maybe it's not. But your square root does not have to have an x-intercept or y-intercept. It can have neither, right? Depending on where our graph starts. I don't know if there was any that we had that had neither x-intercept or y-intercept. But depending on where we graph, it could have neither x or y. Yes, this one right here. So this one here has no x-intercept or y-intercept, right? Because it starts past the x-axis and past the y-axis. All right, so a little review of x and y intercepts with radical graphs. Thanks for watching.